If someone asks you, what is a big number? You might say 100 or 100,000 or a million, but ultimately it depends on the context. In this video, I'm going to go over some of the biggest finite numbers that we have found a use for. So let's get started. First, let's take a look at cards. Alright, so if we take 3 cards like this, there are many possible ways of arranging them. For example, this is 1. That would be 2. There we'd have 3, 4, 5, and 6. These are all the distinct possible ways of arranging these cards. And this comes about because when we have our first spot here, we have 3 different options to choose for that spot. So let's just take this one, for example. And then when we come to our second spot, we only have 2 options. So we can take this one. And for our final spot, we only have 1 option for what can go there. And so this ends up becoming 3 options, 2 options, and 1 option. In the mathematical field of combinatorics, this would be solved by multiplying the number of combinations at each stage. So 3 multiplied by 2 multiplied by 1, which you may recognize as 3 factorial, where the factorial just means multiply that number by all the numbers below it. Now imagine an entire deck of 52 cards and all the ways to arrange that, which of course would be 52 factorial, or 8 over 8 times 10 to the 67th power, which is 8 with 67 zeros on it. For comparison, the number of atoms in the Earth is only around 1.33 times 10 to the 50th power. Now this number is so huge that every time you shuffle a deck, the chances are that no one has ever shuffled that exact arrangement before. In fact, if we had 1 trillion people, each shuffling a billion decks of cards every second since the Big Bang, they wouldn't have even got through half of the possible combinations. But now let's get bigger and move on to the number that inspired the name for the company Google. A Google, as named by the 9-year-old nephew of a mathematician, is defined as 10 to the power of 100, or 1 with 100 zeros after it. And this takes us bigger than the number of atoms in the universe, which is estimated to be between 10 to the 78th power and 10 to the 82. Even larger than that, we can get to a Googleplex, which is defined as 10 to the Google. And now we've gotten bigger than the largest discovered prime number, 2 to the power of 82,589,933 minus 1. And this prime number has 24,862,048 digits. Okay, so those are just some names for big numbers, but what about actually useful ones? So one of the biggest numbers to ever have actually had a use is known as Graham's number. And this number is actually so big that if you were able to store all of it in your brain, it would collapse into a black hole. Now, in order to express this, it's so big that we can no longer use the power notation. So we have to come up with another different method of notation called arrow notation. So 3 arrow 3 is just 3 to the power of 3, which is 27. And that's simple enough. So when we get to 3 arrow 3, or 3 double arrow 3, so that becomes 3 arrow 3, or 3 to the power of 27. And you can get the idea as it continues to higher numbers of arrows. So now we're going to define a number of G1 as 3 with 4 arrows to 3. And this is already so big, it's just crazy. So what we're then going to do is we're going to call another number G2. And that's going to be 3 arrow for G1 arrows, all the way to another 3. And we're going to do that again with another G3, which is going to be 3 with G2 arrows to 3. And we're going to do that all the way to G64. And that is Graham's number. Now this number is so big that we don't even have enough stuff in the universe to write it all down. If we were to write one digit on every atom in the universe, we would run out of digits before we even got near to the end. That's all for this video. Thanks for watching, and I hope you enjoyed learning about some of the biggest numbers we've ever used. Also, don't forget to hit the like and subscribe button if you enjoyed the video.